Okay, equations with rational or, yeah, I can't talk. Equations with radical or rational exponents. So first let's talk about radicals and rational exponents and the relationship between the two. If we're looking at something like x to the 1/2, that's the same thing as the square root of x. Likewise, if we're looking at x to the 1/3, that's the same thing as the cube root of x, right? So that denominator in the rational exponent indicates the index of the root. If I have a numerator in that exponent as well, so something like x to the 2/3, that's the same as, so that denominator would be the index, and the numerator is the exponent. And you know what? It doesn't matter if the exponent is on the inside or on the outside. It actually simplifies exactly the same way. All right, so how do we apply this to equations? If I take something like x plus 1 to the 1/3 equals 3. Okay, this is exactly the same as the cube root of x plus 1 equals 3. All right, so big picture things that we want to think about when we're looking at an equation like this. One is domain, right? It's really important when your equation involves a radical to check your solution. So we're going to be dealing with radicals that have odd exponents and radicals that have even exponents. So one thing to keep in mind is that you can't take the even root of a negative number, right? We can't take the square root of -4 when we're solving an equation over the real numbers. So we can't do this, right? But you can take the odd root, right? If we do the cube root of -8, that's -2 because -2 cubed is -8. So keep that in mind as you're working through some of these things, but to be on the safe side, it's always good to just check your solution. So we're doing a cube root. So really the domain here is all real numbers. So as long as we do our algebra correctly, our solution should be just fine. So in order to get started here, for one, you want to make sure that the expression involving the radical or rational exponent is by itself, right? So if we had been adding something to this or multiplying something to the outside, you want to algebraically get rid of those things first. Since this expression is already isolated, I'm ready to get rid of it. Really, so I'm going to, multiply or actually take both sides of the equation to the third power. Right, so when I multiply here, the 1/3 times 3 just gives me 1. So I eliminate the exponent, and 3 cubed is 27. So x is equal to 26. It's really that simple. The same exact strategy would apply here. You're just looking at a different notation. To get rid of the cube root, I would cube both sides. So again, we get the exact same algebra, and x is equal to 26. A nice quick check would be always go back to the original equation to check your solution. So if I sub in 26, I would have 26 plus 1, or 27, to the 1/3 equals 3. And sure enough, the cube root of 27 equals 3. So I can see that my solution is correct. All right, if we take, let's take an expression that is let's add a numerator to our rational exponent. So let's take, x plus 1 to the 2/3 is equal to 3. All right, so how does this change things? For one, I'm just going to check my solution because that's good practice. But I am taking a cube root, so as long as I do my algebra correctly, I should be okay. Expression with the rational exponent is isolated. And then I suggest rewriting this in radical form. And I'm going to tell you exactly why I make this suggestion. That's a D here. Let me write that legibly for you. So rewrite it in radical form, especially when you have a numerator. And this is why. So if I rewrite this as the cube root of x plus 1 squared equals 3, it just forces me to do this in 2 steps, and you're less apt to make a mistake. So the first thing I'm going to do, just like before, is I'm going to get rid of that radical. So I'm going to cube both sides. So what happens now is I have x plus 1 squared is equal to, 27. And in fact, I'm just going to leave that as 3 cubed. And now, actually, let's rewrite that as 27. That makes more sense. All right, so now we need to take the square root of both sides. So to get rid of the square, I'm going to take the square root of both sides. But what happens when you take the square root of something squared? This side can be positive or negative. So the square root of something squared, this is just going to be x plus 1, but this equals plus or minus the square root of 27. So don't forget, when the index of the radical, which in this case is 2, is even, and it's the same as the exponent inside, you have to include the plus or minus. Because really, whatever number this x plus 1 is, whether it's positive or negative, you're going to square it. So that means that that expression, that number, x plus 1, could be positive or negative because it's getting squared. So again, with that even exponent, don't forget the plus or minus equals 27. So now my final answer is -1 plus or minus the square root of 27. Now you will have to reduce the radical. And that's why I said at first, sometimes I think it's easier to just leave it as 3 cubed because it can make that then reduction a little bit more obvious. But if you don't, which I think instinct sometimes tells you to just go ahead and write the 27, the easiest way to reduce a radical is to prime factor it first, right? So this is 3 times 9 and then 3 times 3. So yeah, the square root of 27, which I'm simplifying, it's excuse me, the same thing as the square root of 3 times 3 times 3. So if I'm taking a square root, a square factor will come out as 1, right? The square root of 3 squared is 3, and then that root 3 stays underneath. So my final answer is x is equal to -1 plus or minus 3 root 3. Now, what if this example had been given to you this way? And this is probably the most common mistake in this section of homework. So again, we know the process. We're going to follow the process the same way, but watch what happens. So I'm going to follow the same procedure and rewrite this as the square root of x plus 1 cubed equals 3. Okay, so to get rid of the square root, I'm going to square both sides. So x plus 1 cubed is equal to 9. Now I'm going to get rid of the cube root, right? So we're going to take the cube root of both sides. So this is different. Remember, when you take a cube root or you cube something, the sign stays. So if x plus 1 is negative, x plus 1 cubed is negative. The cube root of x plus 1 is negative. If x plus 1 is positive, the cube of that number is positive as well. So we don't need the plus or minus. So when the index and that exponent are odd, this is just x plus 1 is equal to the cube root of 9. And my final answer is x is equal to -1 plus the cube root of 9. The most common question that I get in this whole section of homework is, when do I need the plus or minus and when don't I? And that's an important thing to understand. So notice this really has to do with this step, which is why I recommend rewriting it as a radical, because I think it makes it more obvious. It's when this the index and this exponent are even, that you need that plus or minus, because again, that number x plus 1 can be positive or negative because it's being squared or taken to an even power, which is always positive. In this case, the sign of the number x plus 1 will stick. So there's only one solution. So it's important to notice when you need the plus or minus and when you don't. So then as a final step, again, you always want to make sure those radicals are reduced. Since we're looking at the cube root of 9, again, it's nice to prime factor that. That's just 3 times 3. We would need 3 of the same factor to be able to take a cube root, so that's completely simplified. And that is my final answer. Okay, I hope that helps. Let me know if you have questions.